So now we're going to review systems of equations. We're only going to review the substitution and elimination method. Substitution first. So when you are using the substitution method, you need to pick a variable that you want to isolate, and it just needs to be in one of your equations. So typically, the variable that has the coefficient of 1 or -1 is the easiest to isolate. So if we look at question number 1, my top equation has y has a coefficient of 1, and my bottom equation y has a coefficient of -1. Now, the coefficient of 1 is actually the easiest one, or the easier one to isolate. So let's go ahead and isolate y in my top equation. So I'm first going to add the 4x over and I get y is equal to a 6 plus a 4x. And that's it, y is isolated. So now what we do is we take that 6 plus 4x and we need to substitute it in for y in my other equation. You cannot substitute it back into the same equation that you isolated it in. So when we use substitution, we need to remember to put parentheses around what we're substituting in. Because we are going to need to distribute this negative inside my parentheses. So I have a -5x minus a 6 minus a 4x is equal to a 21. I'm now going to combine like terms. A -5x minus a 4x is a -9x. Then minus a 6 is equal to a 21. I'm now going to add that 6 over. So I get a -9x is equal to a 27. And then now dividing by -9 on both sides, I get x is -3. Now I don't just find x, I need to find y as well. So what I do is I take this x, this -3, and I put it in for x in my equation that I isolated y in, because that's the easiest one to do. So I have y is equal to a 6 plus a 4 times a -3. Well, a 4 times a -3 is a -12. So I really have a 6 plus a -12, which gives me a -6 for y. And then what we do is we write our answer as an ordered pair. In an ordered pair, the x value comes first, separated with a comma, and then the y value follows. This is my answer. Technically, what we're trying to find here is where these two lines would intersect on the graph, and they would intersect at the point -3, 6. Now in number 2, I do not have any variables that have a coefficient of 1 or -1, so this one's a little bit trickier. However, what we're going to do is we want to isolate the variable that has the coefficient that all the other terms are divisible by. And if that doesn't exist, then you'll have to work with fractions. That's just the bottom line. But for this one, we have the x coefficient in my top equation. If I divided this entire equation by 2, all of these are divisible by 2. So that makes it easy for us. We're not going to have to work with fractions. We are going to isolate x in my top equation. I'm first going to subtract a 6y from both sides. So I wind up with a -2x is equal to a 6 minus a 6y. But then I need to divide both sides by -2. And so I get an x is equal to a 6 divided by a -2 is a -3, and a -6y divided by a -2 is a +3y. Now I need to take that -3 plus 3y and I substitute it in for x in my other equation. So I have a -7 times a -3y, or sorry, a -3 plus a 3y plus an 8y is equal to a -5. Using the distributive property, I'm going to distribute that negative in. So I have a positive 21 minus a 21y plus an 8y is equal to negative 5. I am now going to combine like terms. And so what I would do is I would combine the negative 21y with the 8y. And so I get a 21 minus a 13y is equal to a negative 5. I am now going to subtract that 21 over. So I get a negative 13y is equal to a negative 26. And then I'm going to divide by negative 13 on both sides to get y is equal to 2. So then I'm going to take that 2. I'm going to put it in for y in the equation that I isolated x in. So I have an x is equal to a negative 3 plus a 3 times a 2. A 3 times a 2 is a 6, so I really have a negative 3 plus a 6, and a negative 3 plus a 6 is a 3. So x is 3. So then I write my answer as an ordered pair. My x value came out to be 3, my y value came out to be 2. These lines would intersect at the point 3, 2. So that's substitution. Now we're going to review elimination. So with elimination, key things are you want your x and y values to be on the left side of your equation and your constant on the right. In number 3, both my x and y values are on the left and my constant's on the right. That's good. That's what we need to happen in order to do the elimination method. Now what you're going to do is you're going to add these two equations, but the goal is to eliminate a variable. If I added these two equations right now, a 5x plus a 10x would give me a 15x, so that variable would not eliminate, and a 1y minus a 7y does not eliminate as well. So what we're going to need to do is we're going to need to multiply one or both of these equations by something, so that way when we do add the equations together, we eliminate a variable. So for this one, if I multiplied my top equation by 7, then I would eliminate a variable because my y values would have opposite coefficients. I would have a positive 7 for my top one and a negative 7 for my bottom one. But we need to be careful. We need to multiply the entire equation by 7 because then it does not change the value of your equation. If you do not multiply your entire equation, then it does change the value. So multiplying everything by 7 in that top equation, a 5x times a 7 is a 35x, a plus y times a 7 becomes a plus 7y, and a 9 times a 7 becomes a 63. Now I can add these two equations together. A 10x plus a 35x is a 45x. Whoops. A negative 7y plus a 7y, that eliminates, and that would equal a negative 18 plus a 63 is a 45. So now this blue equation, I just have one variable, and I can solve for it by dividing by 45 on both sides, and I find that x is 1. So now what I need to do is I need to find y, and I'm going to put that 1, that x value of 1, into one of my original equations. It does not matter which one. I'm going to put my x value of 1 into my top equation. So I would have a 5 times a 1 plus a y is equal to a 9. And now I'm going to solve for y. So I have a 5 plus a y is equal to 9. And then subtracting 5 from both sides, I wind up with y is equal to 4. So then my answer, I write it as an ordered pair. My x value is 1, my y value is 4. This is where the two lines would intersect on the graph. Now in number 4, there is not a possible way that I can just multiply one equation by a number. So you need to decide, do you want to get rid of x or do you want to get rid of y? I'm going to get rid of y only because they already have opposite signs. So I just need to multiply my top one by the coefficient of y in my bottom equation, and my bottom equation by just the positive version of my coefficient of y in my top equation. So doing this at this time, a 9 times a negative 7x would be a negative 63x. A 9 times a negative 8y would be a negative 72y. And that would equal a 9 times a 9, which is an 81. In my bottom equation, I would do an 8 times a negative 4, which would be a negative 32x. An 8 times a 9y is a plus 72y. And an 8 times a negative 22 is a negative 176. Now adding these two equations together. A negative 63 plus a negative 32x gives me a negative 95x. Oh, should have went in blue, sorry. A negative 72y plus a 72y eliminates the y's, which is what you want. And an 81 plus a negative 176 is a negative 95. So now in this equation, I'm going to solve for x by dividing both sides by negative 95. And I promise the x value will not always be 1, but in this case it also worked out where the x value was 1. So now I'm going to take that x value of 1, I'm going to put it into one of my original equations. It does not matter which one. I'm going to do the bottom one this time. So I have a negative 4 times a 1 plus a 9y is equal to a negative 22. And now I'm going to solve for y. A negative 4 times a 1 is a negative 4. Then I'm going to add that 4 over. And then lastly, I'm going to divide by 9 on both sides to get y is equal to negative 2. Writing my answer as an ordered pair, my x value is 1, my y value is negative 2. All right, this was your review of solving systems of equations.